Welcome to this third tutorial, during which we will see how we can generate heterogeneous refinement meshes using ZephyCFD. So in the previous video, we have seen how we generate homogeneous refinement mesh. So what is the difference between homogeneous refinement and homogeneous refinement means that we will be applying the same level of refinement inside the entire area of interest, whereas by using heterogeneous refinement mesh, we will be able to add some refinement at key locations. So let's start, for example, by using the same resolution that we had for the prevailing direction of 38 meter. So we'll be using this time a ratio of 2 for the heterogeneous refinement, which means that we will be having a resolution twice higher at key locations. And starting from key locations, the mesh will be increasing the size of the cells from the key locations towards the edge of the interest area, and then starting again towards the boundary, the site boundary. So here we can see how the mesh has been refined towards the area of interest. So one interesting thing to see here is that we have managed to reduce the number of cells from 1.7 million using a homogeneous refinement mesh down to 1.1 million without compromising the resolution around the area of interest. So now let's go a step further. Let's see how we can even increase this ratio of refinement by using a ratio of 5. So here we can see that we have managed to reduce again further the number of cells from 1.1 million down to 600,000 without again compromising the resolution of 38 meter around our key locations, so our met mast, our turbines, etc. So we can see here the ratio between resolution at key locations and resolution at other areas inside the area of interest has been increased. So now let's see with a ratio of 10 what would be the output. So we see that now the number of cells has decreased to 450,000 cells, again without compromising the accuracy, which means the resolution around our key locations. But we will be able to have, of course, faster computations without compromising the accuracy of our results. So here we can see now that there is an obvious difference between the resolution at key locations and at other areas. So this will be, of course, very helpful if you are basically running calculations with high resolution at key location on a very short amount of time. By generating a report, as we did earlier, we can compare all the different meshes. So from the mesh that we built with homogeneous refinement of 1.7 million cells, we can see how the number of cells has gone down to 450,000 using the same resolution, but a ratio of refinement of 10. So this is the heterogeneous refinement, and we will see how it is when it comes to a ratio of 10.